This is a quick review of how to add and subtract fractions with unlike denominators. Core strategy for this type of problem is to find an equivalent fraction that makes both denominators have the same value. Our first problem is going to show this. We're going to do 3/4 minus 5/12. Right now we have different denominators. We have two different strategies to find an equivalent fraction. The first strategy we're going to use is picture models. First, we will represent 3/4, and then we will represent 5/12. Three boxes out of 4 represents 3/4. Five boxes out of 12 represents 5/12. To get an equivalent fraction, we will split one of these shapes. If I split this shape, I'm going to get an even smaller number of divisions, which is going to make my denominator have a greater value. So I need to split the other side. However, if I just split it one time, we should ask ourselves, is it equivalent? Well, one of these boxes is worth 1 out of 12. One of these boxes is worth 1 out of 8. That's not equivalent yet. I need to split it differently. That's why I used a pencil. So I'm going to split it now twice. Now, one of these is still worth 1/12. One of these is worth 1 out of 12. That means we now have two equivalent shapes. So what is the new equivalent fraction? Well, we have 9 pieces shaded in out of 12 total, so that's 9/12 minus still 5/12. That gives us a subtraction of 9/12 minus 5/12 for 4/12. We can take this a step further by simplifying. 4 and 12 have a factor of 4 in common. If we divide both by that factor, numerator and denominator, we get 1/3. Our first model here is called a picture model, but there's another method that's even more efficient. It's called least common multiple, or just common multiple. Let's see how that works. We're going to rewrite the same problem, 3/4 minus 5/12. Instead of drawing pictures, we're going to consider, do these denominators have a common multiple? Well, I know I can multiply 4 to get 12. How many times? I've got to multiply it 3 times. Whatever I do to the denominator, I must also do to the numerator to keep it equivalent. 3 times 3 is 9. 4 times 3 is 12. And I can rewrite 5/12. Now I have a problem with equivalent denominators. And of course, if you're looking carefully, it's the same problem as above. Therefore, I can get 4/12. I can divide by a factor of 4. I can get 1/3, just as I did. The least common multiple, or the common multiple method, is much more efficient than the picture model method. However, both of them work. Both models, both strategies will help us to find an equivalent fraction that makes both denominators have the same value. Let's see that again with one more problem, and then I'll give you some practice to do on your own. Problem B is 5/6 plus 2/3. Now, you'll notice in the last problem, I only needed to change the fraction that was in the front. In this problem, I'm not going to need to change the fraction that is in the front. Let's represent it with a picture first. We're going to represent 5/6 and then 2/3. Five equal pieces out of 6 is 5/6. 2 equal pieces out of 3 is 2/3. And now what we need to do is split the shape so that we can find an equivalent fraction. If I split this one, I'm going to get 12ths. That's not going to get me closer to having equivalent fractions. If I split this one time, now this is worth 1 out of 6. This is worth 1 out of 6. So I found an equivalent fraction. Here we have 5/6 plus 1, 2, 3, 4/6. When I add this, I'm going to get 9/6. That's an acceptable answer, but that's a fraction greater than 1. We can take that one step further and convert to a mixed number, getting 1 3/6. We can take that one step further by recognizing that 3 and 6 share a factor of 3. If we divide both by that factor of 3, we get 1 and 1/2. Let's try that using least common multiple. Well, our original problem was 5/6 plus 2/3. I can't multiply 6 to get 3, but I can multiply 3 to get 6. 3 times 2 gets me 6. Whatever I do to the denominator, I must do to the numerator. If I rewrite that problem, I'm going to get 5/6 plus 4/6. And of course, we could follow that to get our same answer just above, because we got the same type of problem. Okay? So at its core, the strategy is to find an equivalent fraction that makes both denominators have the same value. You can either use picture models, or you can use least common multiple, which is slightly more efficient. I'm going to show you now 3 problems. Pause the video now and try 3 problems. You notice that the last one's a challenge problem. Many students ask, well, what happens if you can't just change one denominator directly into the other? We can't turn 4 into 3. We can't turn 3 into 4. Remember that our strategy is to find a common multiple, a common denominator for both. So try out the challenge problem and see if you can do that on your own, but it goes a little beyond our 5th grade curriculum. Once you've paused and tried the practice problems, you can play again, and I'll reveal the answers just below. So pause the video now. All right, here are the answers. Check yourself, find any mistakes, and move on to a new skill.